So following on from the previous video, we were trying to develop a way of working out the area between A and B here. And the way we would do that is to split this up into small strips. So we would get B minus A divided by it, for this particular moment, divided into 4 strips. Okay, so that would then represent our delta x. So delta x would be here. So this length here would be delta x. And then once we've got our delta x, then right at this point here will be a plus delta x. We would then put this into the original function. That would then give us the height. That's the height here. And then the width here is delta x. So the area of this thing here will be this times this. So now we need to look at this this rectangle now. Okay, we need to look at this rectangle. So the second rectangle would be well, if this here is delta x, if from here to here is delta x, and from here to here is delta x, then the x coordinate here will be a plus 2 delta x. Okay, so the coordinate, the x coordinate here will be a plus 2 delta x. So now put this into the original function, and then that will then jump straight, allows us to jump straight to here. Okay, so the height of this rectangle here is given by this, because this bit here is so when we put this into the original function here, that will then give us this thing here. Okay, so the height of this rectangle here is given by this, and now we need to times it by the width. The width here is delta x. Don't forget, delta x is also from here to here. Delta x is also from here to here. Well, the width of this rectangle is delta x. So we need to times it by the width. So the area of this rectangle here is given by the height times the width, which is given by this. Okay. Now we need to consider the third rectangle now. So this third rectangle. Well, the third rectangle would be so delta x is this length here. This is delta x, and this is also delta x. So from here to here is delta x. From here to here is delta x. From here to here is delta x. Well, the x coordinate here would be a plus 3 delta x. So now put this into the original function here. That would then allow us to jump straight to the height here. Okay, so when you put a plus 3 delta x into the function here, that would then give you this. So this here is really the height. Okay, so now you've got the height, you need to times by the width, which is delta x. So the area of this rectangle here is given by this. Okay, now we need to consider the last rectangle here. So the last one, well, same idea. The last one will be well, the x coordinate here would be hang on, the x coordinate here would be a plus 4 delta x. Okay, so hang on. So this here is a mistake. It should be a. Okay, so this thing here would be a plus 4 delta x, and then put this into here, and then that will give you the height. So get the height times the width here. Same idea. So now the total area here would be don't forget, this here is the area of this one here, this rectangle here. This area here, remember 2 delta x here would be the area of this one here, and then this one here, remember this is 3 delta x, would be the area of this rectangle here, and the last one here would be the area of this one here. So you add them all up. But the overall area is given by this ugly thing here. Okay, but then we can tidy it up. So now we can use our sigma notation here. So remember, when k equals 1, you put the 1 into the k here. So that would then represent this first part. Okay, and then the second part, you would increase the k by 1. So take it to 2. Put the 2 into the k here. That will then give you a plus 2 delta x. 2 delta x. So when k equals 2, it will give us this part here. Now increase the k to 3. So when k equals 3, you put it into here. Oops. You put it into the k here, and then that will then give you this part. Okay, and then increase the k again to k equals 4, which is our last term here. Put the 4 into the k here. That will then give us this thing here. So the point here is that this ugly thing here can be rewritten in a neat form here. Okay, and you see, when you look at this, what's changing each time is this k here. You're increasing the k by 1 each time. So it's a k that's changing, that's moving about. So this here is in a way a constant. Is a constant. So we can actually take the constant out here. So it becomes this. Okay, so this can then be written as this. And if you don't understand why you can take this out here, then consider this. Consider this. Hang on. So the total area of this thing is given to us by this. But let's assume that you don't understand why you're able to take this delta x out here. Let's just say delta x. Well, when you get b, take away a divided by n. Let's just say delta x here is 2. Okay, let's just say the length here is 2. Delta x here is 2. Delta x here is 2 and 2. Let's just say the height here is 3. Okay, let's just say the height here is 5. Let's just say the height here is 7, and let's just say the height here is 8. So when you look at this here, okay, when you look at this here, when k is 1, you put the 1 into here. Okay, so that will then, well, when you put 1 into the k here, it will then give you f of a plus 1. Remember, when you put 1 into here, it will then give you just delta x. Okay, now so this thing here represents the height. So the whole thing here is 3. The height here is 3. That's this 3 here. So the point here is that when you put 1 into here, this whole thing here is 3. Okay, and then delta x is just 2. Okay, and then when you increase this to a 2, put the 2 into the k here, then it will become f of a plus 2 delta x. Well, when you put a plus 2 delta x into the function, it will then give you, in this case, it will then give you 5. So hang on. So when you put 2 into here, this whole thing here is 5. So when you put 2 into here, when k equals 2, then this whole thing here is 5. When k equals 3, when k equals 3 here, when you put it into here, it will be 7. So when you put k equals 3 into here, then this thing here, then this whole thing here will be 7. Don't forget, delta x is always 2. Delta x is always 2. Delta x is always 2. Now when you increase this again to 4, put the 4 into the k here, then this whole thing here will be 8. That's this height here. That's this height here. Okay. So the point here is that when you sum up all of these, you can see that 2 is in common with all of them. So you can actually take the 2 out. So when you look at this here, it's just 2 all the time. It's just a constant. You can just take it out here and concentrate on summing up all these here. And then once you've summed them all up, you can just times it by 2. the point here is that delta x here is a constant because it's the k, that's always changing. So because it's a constant, you can actually take it out here. Okay, so we are now at this stage here, right there. So the when you sum up all the when you sum up all the rectangles, it will give you this. Tidy up, it will then give you this, and then delta x is a constant. You can take it out here. So we are now at this stage. Okay, I will continue in the next video.